We are going to be looking at a problem from section 5.5. This is number 16 on investments. The purpose of this problem is to look at the compound interest formulas, and this is for the following. It says, suppose that $6,800 is invested for X years at 7% interest compounded annually. We want to find the future value of the investment at the end of 10 years, 30 years. And so looking at this, after I get my pointer set up here, all right, now the first thing you need to recall is what the formula is that we want to use for this. And the formula that we're going to use for this particular problem is the following. We're going to use the formula from the textbook where S, in other words the future value, is equal to P, the original principal, times the quantity 1 plus R divided by K, raised to the K times, and I'm going to use X for the time on here. In this formula, the R is the interest rate written in decimal form, so our 7% is going to be 0.07. K is the number of compounding periods, and in this particular problem, since it's compounded annually, our K is equal to 1. And so we're going to get the following, okay? And when we substitute our numbers in here, the P is the original principal, so that's the 6,800. And then we're going to have 1 plus, this is going to be 0.07. Since the K is 1, I don't have to divide, raised to the X. For this first problem then, when we work this out, this is going to be equal then to 6,800, and we're going to have times 1.07 raised to the 10th power. Let's take our calculator over here, and I'm going to make it bigger so that we can see it. That looks pretty good. Let me move it here. Now, if I turn the calculator on and clear out what's on there, here we go. We can compute this quite quickly. We're going to have 6,800, and then we're going to have times 1.07, and this is raised to the 10th power. And the answer is approximately $13,376. Okay? And my textbook has a different answer. That's because I have a different number. So the textbook, the actual problem is supposed to be 6,400, but I'm going to just stick with my 6,800. And so the answer that I'm getting for this problem is going to be $13,376 and about 63 cents. So in other words, it hasn't quite doubled in value. Okay. For part B, using the same formula, we're going to have S is equal to the 6,800. We're going to have still times 1.07, but this time our X value is equal to 30. And so putting this in, rather than doing it from scratch, I'm going to do second entry, and I'm going to back up and I'm going to change that to a 30. Enter, and the answer for this one then is going to be $51,763 and about, that's supposed to be a decimal point, 33 cents. So these are the two answers to my slightly different problem number 16.